So today we're going to talk about in CircuitPython, how do you read the FlySky i6 receiver, connect it up to a Rover that's controlled in tank drive using servo motors, and how you can have your own RC controlled Rover in CircuitPython. All right, so wiring. This project assumes a couple really important things. The first, it assumes that you're using the FlySky controller and the library that I've written up for that. You can see that in the description down below. It also assumes that you're using a FlySky i4, i3, i6, or i7 receiver. It also assumes that you have two servo motors, two continuous servo motors connected to your microcontroller somewhere in a tank-style drive on your Rover. So one side of your Rover is controlled completely by one motor, the other side is controlled by another. So a really common setup, you may have something like this and a caster setup. So once you've got that wiring set up, we can actually get over to programming an arcade-driven robot. Kind of like the Rover you saw in the beginning of this video. So the first thing we're going to do is we're going to import board. We're going to import time as usual. Just like in the last video, we're going to import RC. And we're also going to say from arcade drive servo, we're going to import drive with a capital D. Now, in order for this tutorial to work, you have to make sure that on your CircuitPy device, inside your library folder, you do have the arcade drive underscore servo.py file in there. I'm going to link that in the description down below for you. So just like in last video, we're going to initialize our RC object. And we're going to say channel 1 is equal to, in my case, it's board D10, same thing as last time. Channel 2 is equal to board.D11. Channel 3 is equal to none. Channel 4 is also equal to none. Channel 5 is equal to board.D12. And then channel 6 is equal to board.D13. Now let's make our arcade drive class. So I'm going to say drive, or sorry, not class. We're going to create an instance of an arcade drive. And we're going to say drive with a capital. And it takes 4 arguments. The left pin is whatever the left side of your Rover is going to be. In my case, it's going to be board.D1. It also takes a second argument of right underscore pin. And this is going to be board.D2 in my case. And then there's 2 other optional arguments you can use. There is left stop is equal to 0.0 and right underscore stop is equal to 0.0. Some rotational servos do not have the ability to program and fine tune with a screwdriver the stop value. So I've put in the option here that you can change the stop value in code. So let's say maybe 0.01 is the actual stop value for your left motor, or it could be even something like negative 0.015 or 12, whatever have you. So I put in 2 optional arguments. If you are putting in your servos and you're doing them manually with a screwdriver for their stop values, you do not have to put in those 2 optional arguments. And then comes time for our main loop. So we're going to say while true, we're going to say spin is equal to rc.read underscore channel, and channel 1 is our spin value, and throttle is equal to rc.read channel 2. Then if spin is not none and throttle is not none, then we can actually call drive.drive with spin and throttle. And then we can print what our spin value is, spin, and then throttle. So we have to have this line in here because occasionally your RC receiver is going to return the value none. And if you're trying to call drive.drive with a value of none as opposed to an integer from 0 to 100, you're going to end up having a bad time. Your program's going to crash because it's not going to accept that as an argument. So you have to check to make sure that you are reading a valid signal. And if you are reading a valid signal, then you should send it out to your driver. Now, in terms of how drive.drive works, If you send a value of 50, that's the equivalent of stop. If you send a value of 0, that is max reverse. And if you send a value of 100, that is max forward. Yeah? So if I were to say drive.drive 50/50, that would be a complete stop for my rover. So let's go ahead and let's save this over to our CircuitPy device. We'll open up our serial port, and we can see if we were to start driving our rover around. Let's move this over. Right now, it's currently stopped completely. I've also programmed a bit of a dead space, so you can tap this thing ever so slightly. And just in case your joystick does not come back into the middle, you can still have it at 50 as you expect. So as I move up, you'll notice that throttle goes up. As I come down, throttle starts to come down. As I move to spin, spin starts to come down, and spin starts to come up as I move around. And what this lets you do is it lets you strafe your rover around and control it forward, backwards, left, and right to spin in place using a single joystick. So let's take a look at this in action on a scale model of the Rosalind Franklin rover.